Hi, my name is Paul Montalvo and I will teach you about new exponent laws when you're switching numbers from power form to root form. But to start off with our lesson, let's talk about specifically what is an exponent. An exponent is a number of times a number is multiplied by itself. So let's say you have 5, for example. 5 to the exponent of 2, which is the same as saying 5 to the power of 2, is the same as saying 5 times 5. As you can see, the 2 is the number of which how much it's multiplied by itself. So since there's a 2 as the exponent, 5 is multiplied by itself twice. The new exponent law of which I will be teaching today involves when you are to get a big base number and you get an exponent of which is a fraction. And as you know, let's talk about the example I used before, 5 to the power of 2. Like we said, that is 5 times 5. But if you were to get an exponent of which is a fraction, you can't specifically do that. You can't do how we did it last time with 5 times 5 because this time it's half a number. Because this is technically 5 to the power of 0.5. So using this new exponent law, you'll be able to do so. So this new exponent law involves variables. Variables are just letters of which represent any number you would like it to be. So this new exponent law is A, which represents your big numeric base. In this situation, as before, it would be the 5, like I used before, to the power of m over n is equal to the nth root of a to the power of m. As you can see, the m represents the numerator in the exponent given, and the n represents the denominator in the exponent given. Now let's go over some examples to enforce the new exponent law which we just learned. So let's say you're given 6v to the power of 1.5. So first we're going to look at the exponent. 1.5 is a decimal. Decimals can also be written as fractions because 1.5 is also equal to 1 whole and a half because it's 1 and then the 0.5, of course. So if we're going to use a denominator of 2, we could safely say 1.5 is equal to 3 halves, right? Saying that, let's rewrite 6v to the power of 3 over 2. Once we put it into this form, we can already see our big A value, our M value, and our N value. So let's write it in the root form. So as you know, I'm just going to rewrite our main exponent law is a to the power of n to the nth root. So as you know, we see the big A value right here in the 6v. So let's put that under the root. And then the M value is 3. And then the nth root is 2. So this is square root to 6v cubed. Now we're going to go over situations when you were given a number in its root form and you have to put it back into its power form. So let's say if you're given a cube root of x to the power of 17. So all you have to do right now is just work backwards from the rule we talked about before. All you're doing is finding the placeholders of each variable and putting it back into its a to the power of m over n form. So as you can see, under the root, the big numeric base is the x. So it's the cube root of x to the power of 17 is equal to x. That's the big numeric base. And then all you have to do is look for the m and n values. The 17 on the x, or the power x to the power of 17, is the m value, so it's the numerator of the exponent. And then the denominator is the, as you can see, the 3, so it's the cube root. So it's going to be in the n spot, so you put it on 3. And yeah, that's all you have to do. You're legitimately just working backwards, and you're finding the placeholders and putting them in its correct and respective spots. So I'm going to go over two more situations when it comes to exponents with fractions. But in this situation, if you are to get a exponent as a fraction which is negative. So first I'm going to introduce another exponent law of which you may have learned in the past, is if you are to have a, which is your big numeric base, to the power of a negative exponent, that is equal to the reciprocal of a to a positive exponent. So keep this in mind when we're going over the examples that we go on next. Let's say you're given 3 to the power of negative 1 over 5, and you have to put this into its root form. So to approach this question, we are going to use the exponent law which we just learned, which is a to the power of negative m is equal to a's reciprocal to the power of opposite m. So we're going to use the law which we learned from the beginning and put it into its correct form. So as you know, this is going to be the fifth root because 5 is in the n spot and 3 is in the big A spot, so that's going to go under the root to the power of negative 1 as that is in the m spot. So all we're going to do in this situation is follow this law that I just talked about, and we're going to get the reciprocal of 3 and then get the opposite exponent. So all you're going to do is rewrite the root, write the reciprocal of 3, and then, like I said, the opposite exponent, which is just going to be 1. So this is 3 to the power of negative 1 over 5 in its root form. So you can safely say 3 to the power of negative 1 over 5 is equal to the fifth root of 1 over 3. In this last situation, let's say you were given a root or something in root form and has a fraction under the root with a negative exponent. So let's say to the 18th root of 1 over 36 to the power of negative 2. So now let's just work backwards from what we had before. So as you know, the denominator of the number under the root has a negative 2. And if we were to flip that, according to the law that we just learned with the negative exponent, with the reciprocal, if we were to flip this, it will change this 2 over here to a positive. So let's say we flip the reciprocal, 36 over 1 to the power of 2. And now we're back to the form that we had before in the beginning, but this time without the negative. So all you're going to do from this point is you're going to get the main form, which is a to the power of m over n, and you're going to place the numbers in its correct positions. So as you see, the 36 over 1 is the big base, so 36. The 2 to the power of 2 is in the m spot, so it's 2. And then the 18th root is in the n spot. And if you want to further simplify, you could divide these two out by 2. So you could technically say 36 to the power of 1/9. Now overall, you could see that the 18th root of 1 over 36 to the power of negative 2 is equal to 36 to the power of 1/9.